Okay, on to the last question for the transformation section. Write the transformation matrix for a 2D object that is reflected across the y-axis, then translated up by 1 unit, to the right by 3 units, then rotated around the origin by 90 degrees counterclockwise. Okay, so since we are trying to do multiple different transformations, we can write out each of these individual transformations and then multiply these 3 matrices together in order to get our final transformation matrix. We can also just leave it as a product of these 3 matrices. So let's start with the very first one. So the first one is a reflection across the y-axis. So as we saw in lecture, if you want to reflect across an axis, then all you have to do is negate it. So we have -1 here to negate all of the x-coordinates, and then everything else would be just like the identity matrix. Okay, and notice one thing, I've written it way over on the right because, as we know, transformation matrices are applied right to left. So since this is the first transformation, I'm writing it on the right. Okay, then the next thing we need to do is translate our object up by 1 unit and to the right by 3 units. So, also seen in lecture, all of our transforms for translations will just be in this last column here, kx and ty, and then everything else will stay the same. So since we need to translate up by 1 unit, our ty will be 1. And if we're translating over by 3 units, over right, then that'll be 3. Just a note, if we're translating left, then it would be -3. Okay, and then on to the last transformation. That's a rotation, and luckily for you guys, we just did rotations up here, so we can just copy it, be cos 90, sine 90, negative sine 90, cos 90, like that. And then we can also simplify this here if you want, and that would just look like this. Okay, so then all of these 3 matrices together will give us the transformation that we want. And then all we would do is just multiply our coordinate over here, and that would give us our new transformed coordinate.